Okay, welcome back. And now what we're going to do is we're going to talk about graphs of polar equations. So this is where we're going to use polar equations and we're going to investigate how do we graph polar equations. And again, we're looking at the relationship of how does r change when as theta changes, right? So that's the idea. What direction is it going? So we're going to use a lot of things in here, and we're going to start with point plotting, by plotting points, and then we're going to also go on and look at symmetry later on and other ways that we could plot. But let's look at this equation, r equals 4 sine theta. Okay, so we've got this table, and what I'm going to do is I'm just going to write down the values of r given theta as we go from 0 to 2 pi. So we're going through one revolution, right, of the circle, or one revolution. I'll just leave it at that. I don't want to say circle, but so here we go. So when theta is 0, r is 0. When we have pi over 6, r is, when theta is pi over 6, r is 2. When theta is pi over 3, we get the square root of, 2 times the square root of 3, 2 root 3. And then at pi over 2, we get 4. At 2 pi over 3, we get 2 root 3. So notice how it goes from 0 to 2, and then something slightly bigger than 2, or almost 2.5. Or almost 3, I guess. And then this would be 4, and now it's going back down, right? And then what about 5 pi over 6? That goes back to 2. And then at pi, it goes to 0 again. So from 0 to pi, it goes from 0, here, and then back to 0. Now what about 7 pi over 6? 7 pi over 6, it goes to negative 2. And then it goes to negative 4. And then it goes back down to negative 2, or back up, I should say, to negative 2, and then to 0. Okay? And so how would we graph this? Okay, think of it this way. Okay, so here's our graph, right? So at 0, we're at 0. And then at pi over 6, right, at 30 degrees, we're at 2. So let's say we're over here. Right? Or maybe up here. Or here, let's do the circles. And we'll go. Don't mind my circles. But here we go. We go to 2, right? And then we go to right, so this is going to be somewhere around here, right? And then at 4, right, up here, at 90, so at 90 it's 4, so we're going to go from here all the way to 4, and then we're going to start going back down, so that's going to be over here, and then over here, and then back to 0. So what do we end up, now that was one full length. Now here, negative 2, right? So at pi, it's 0, right? So at pi, we're back to 0. But then at 7 pi over 6, 7 pi over 6 is over here, right? But then we're going negative 2, which brings us right back over here, right? So what's going on here is we end up having a circle, right, that touches here, But what's going on is when we go from 0 to pi, we're going around 1 revolution. And then from pi to 2 pi, we're going around again. Okay, so we're tracing the graph 2 times as the angle goes from 0 to 2 pi. So it represents, if we look at the rectangular plane, it represents a circle with a radius of 2, and whose the center of the circle is at 0, 2. And it has a radius, radius of 2.